Um, okay, in the last hour, we say that day and time is actually quite troublesome things when you do the computing. It's because that in human civilization, we kind of like chopped the time very in a very strange way, right? Um, Actually, in its nature, it should be a continuous number, a real number type of things, right? Time is actually a continuous things, but it should be like a numeric thing, like you can see a histogram, you can do some computation with time, right? But in the in human society, we kind of like read it in a way that make it like very difficult to compute. And the other thing is that different people write day and time in different format, right? So before we can handle day and time within the computer, we need to do a conversion, okay? So if you have a timestamp, we are using this as POSIX function to do the conversion, okay? Okay, and POSIX is actually international standard timestamp for computer, right? So we just follow the beside the string, you need to specify the format that you used in this character string, and then you can recognize the time and turn that character string into a numeric like time, right? So, and because it is numeric, so you can actually do like histogram, like that type of things, okay? The first thing we want to do is time, is that. And then the second thing that we need to do is sometimes we want to translate this timestamp back to the, for example, we want to know the car stolen event, and we want to know that how many events is happened in Sunday, Monday, Tuesday, Wednesday, that type of thing, right? Then you can actually format. You can use this format function to convert datetime back to string, okay? For example, if you use the percentage W, you can see that percentage and lowercase w is the weekday, 0 is Sunday, and the 6 is the Saturday. And if you use percentage U, and then Sunday will be 7, and Monday will be 1. Okay, so they are different like way to write time and date. Okay, and so you can specify whatever you like to convert it, right? So every time, every event is occur in one of the weekday, right? Okay, and with format function, you can convert this kind of like time, the numeric time, right, back to a character type, weekday or months or hours, right? So if you want to see in the weekday, if you want to count the car thief events by weekdays, right? This is the way to do the count, right? Okay. First of all, you convert this TS. Use the percentage W code. Okay. The percentage W stands for weekday. Sunday is 0. Okay. Then so after you do the conversion, you can do a table, right? So you can see that 26316 car stolen event occur in Sunday, okay, and within the weekday, which day is which day has the most, which is the largest number of car stolen event? Friday, right? Friday is very easy to stolen car, right? Especially Friday night, you can see later, okay? And if you want to see hour, right? You can do format hour, isn't it? Okay? You do format hour, and then you do a table. You can see the 24 hour, right? And you can actually convert this 24 hour and pipe it into a bar plot. And you can see that this is how the car stolen event distributed within the 24 hours. Right? See? Okay? And then actually you can do better. You can do 24/7 kind of table, right? See, you can format it with weekday with the %U code, and then you can format TS into hour and then this hour, and then you can see that in a 7-day 24 hour, right? This is the distribution of car stolen event along the 24/7 type of things, okay? But actually, this is kind of difficult to see, right? So many numbers, a big table here, right? But it's very difficult to see a large table like this, right? So one way to visualize, later on we'll teach you how to visualize this number so you can see the distribution better, okay? If the distribution is just one dimensional, you can very easily visualize it with a bar plot, right? But if it is two-dimensional, usually we will need we will need we call it heat map to see the distribution, right? Okay, this is quite intuitive, right? So we can see that within a day, what is the time that the car was stolen most frequently? This is 24 hour, right? And this is like 7 day, isn't it? Right? And rate, the color means the count. Okay? So what is the most frequent time that car stolen within a week? Louder, say louder. I told you that if you say something that later on you can go to the TA and I will give you some more point at the weekend. So raise your hand, okay?
10 p.m.
Sorry?
10 p.m.
10 p.m. And what day? Friday, right? See? So 10 p.m. Friday is within the 24/7 weekday. You can see the distribution of car stolen event in the heat map, right? And the code is not very complicated. Don't worry about this. We will teach you how to do visualization in the next few weeks. Okay? Okay. So I just want to demonstrate to you that the reason that we want to see how the reason that we want to do computation, do analysis on the time is because that we want to know how the events are distributed within time, right? So and when you use this format type of things, you can kind of like treat time and day as a numeric things, and then you can see the distribution along in the time. Okay? See that? Okay. Now, actually, we will have a lot of like question left empty here, and I kind of left it for your homework assignment. Okay? You know how to do the medium, right? See? Okay? And you want to, what is the month and year of the medium date in your data set, right? So you can use the medium function on the TS to do that, okay? And then what's the months that the fewest modulative event occur? Okay, for example, you want to do this, you can do that. Go to our studio. Okay, yeah. We are here, right? If you want to see the month and year of the medium day in the data set, right? Okay, so you want to do a median timestamp, right? Because timestamp is now, you can treat timestamp as the numeric data type. So you can see the median, right? See? Okay? But you cannot do it directly on this D day. You can also do that, right? But that would not be a correct medium things, because it is non-numeric, right? So its medium is not the same as that what you do in the TS. This is the correct answer. Okay. Is this Xu Tingwei? No. So okay. Now and then how to do this? On which weekday did the most motor vehicle theft occur? We actually already do this already, right? These two things can be, I think these two questions can be answered with one single comment, right? First of all, you do a format. What did I do? Okay, I think. Okay, so you can actually format it. TS, right? And you can do a table, right? You want to format it as a weekday, so the code for weekday is like, you can use %u and then table and then do a sort, right? See? Now you can see that the first motor event, the day, the month, it is actually S for the month, right? So here you need to use M, right? because you want to see the month, right? So in which months did the fewest model thief event occur? Which months? You can see that because I saw it already, right? I do the table to count the month, and then I do a sort to sort them in ascending. So what is the fewest motor vehicle thief occurred? It's here, right? Okay. And on which weekday did the most vehicle thief occur? I'll leave it for your exercise. Okay? You can see that? So which month has the largest number of motor thief for which an arrest event was made, right? You know how to do this? This is the conditional things, right? First of all, you have a TS for, and then you need to select the D arrest, right? This is a you can see that this is arrest, right? Isn't it? Okay? So if you use this logical vector as an index, then this TS is gonna be, right? You would only select this, with this index, you would only select the car stolen event that has arrested, isn't it? Right? If you want to do this with some sorry. This is the number of arrested car stolen event, right? Isn't it? And if we want to know that, we can use it as an index and see and use timestamp here. So this is the timestamp of the event that has been arrested, right? And then we need to format it into months, right? Because it is asking about months, right? So you need to format it as months. See, right? And then you can do a table with it. See? Now this is the car stolen event, arrested car stolen event for each month. See that? Right? And you want to know the largest, right? So you may want to do a sort. See? So the largest thing is like January. You see that? Right? So we are not learning kind of like new index, new function or something. We are just like use the indexing, use the table sort type of function. The only difference is that you need to kind of convert the timestamp, right, into a exposed function, so you can do the computation correctly. You get the point, right? So this is the way to handle time and date within computer. Okay. So now, so it say that does it look like criminal increasing or decreasing from 2002 and 2011? That this is actually can easily be seen in the, if you do a histogram, it's easier. It's easy to see that, right? Okay. So I'll give you as the exercise. There are a lot more things to give you. For example, you're looking for location. Which location are top 5 location for motor vehicle thieves, right? Top 5. So what you want to do is you want to do a table on the location, right? Isn't it? And you do a table, and then you want to do a sort, right? Because it is asking to the top 5, right? Okay? And sort, by default, it's sorting the number in the ascending order, right? In ascending order, so you want to see the tail, right? Because the top 5 is in the tail, right? And 5, you say 5, okay? So so the top 5 is gas station, alley, actually street, but the problem is there's other, right? It want you to exclude the other category, right? So you need to use 6, right? And then exclude the other. The question is say that you want to exclude the other category, right? So, but if I use tail 5, then I only see 5, and one of them is other. So you need to use 6, and then exclude the other. Is that? See that? Right? Okay. So you don't really need to use some very special function code, okay? But as long as you can use the function code that we already learned, you actually can do a lot of analysis already. Okay? You get the point? Okay. So for the rest of the things, I'll leave you as your team homework assignment. Okay? Before I leave this homework, before I leave this case, the last thing I would like to tell you is that there's a Ninja's Dojo, which means that this is the code that in your current capability you are not able to do that. Okay, I just want to see that if you have this type of information, and if you learn programming, you can. If you are a very good programmer, then you actually can do it like this, right? This is the number of events by 24 hours and 7 days, okay, in different locations. As you can see that the time distribution and the time distribution in parking lot, in gas station, and in street, they are different, right? Isn't it? Right? So if you are a law enforcement department, and you can see that actually in different place, the car stolen event are distributed in different time, right? So you can like send out your police to the right time, to the right place, isn't it? Okay? So this is the basic of business analysis, right? You analyze the data and then you want to, it will give you some information so that you can do your business better, right? In this case, you can allocate your law enforcement manpower to the right place, to the right time, so you can improve your arrest rate, right? Okay. See, so this is the, you don't need to do this Ninja Dojo. I just want to show you the potential that if you actually can do analysis, maybe at the end of the semester you would be able to do something like this. Okay. So there are a few quiz. So tell you now from this chart you can see that if you are law enforcement, how can the chart help you, right? A few questions that you can answer. Just write the answer down below here. I mean, you can put the answer just down below here, right? So the first question is just put your answer here. Right? So maybe one. This is like so what can you observe from the chart above? So you can see that it's actually, you can see the right? Okay, just type the answer here, and then you, I would actually, an A2. So if you are law enforcement, how can you do it? How can the chart help you? And if you are a motor thief, how can the chart help you? Okay. If you are a motor thief, how can the chart help you? You see the car arrest event, so you want to avoid stolen car in this time spot, right? It's very high possibility that if you store car in the parking lot at this time, it's very easy to get caught. So, so basically, I'll leave this as your homework assignment, okay? And is there any more question that you are up to this point of time? If no question, I'll go forward to the second case, okay? The second case. Now, again, let's go back to our studio and we can go to the, sorry. we open the RMD for stock price, and then again you can execute the first call chunk, and then and take a look at the HTML first. See, this is the stock market dynamics, okay? So what we have is we will learn how to handle time series data, right? Because the stock price is like a time series, right? Okay, so we will learn how to use line plot to visualize sequential data, and we would learn how to draw multiple lines in the same plot, so you can compare the stock price of different company, okay? And then we will learn how to add some assistant line to help us do the judgment, okay? And then we will also learn how to use the apply function to do a repeated action on a data structure, okay? We'll use the apply function to do some action, to do some repeated action on the corrected object like vector or list. Don't worry about that. We'll have some example to do that. Okay. So first of all, the following data file, the stock price data file are within the data folder. Okay. Here you go to the data folder. You can see that there's a Boeing, Coca-Cola, and also this is General Electronics, IBM, and also P&G. Okay, so they are the big stock, 5 stock here, and we want to read them in, right? So what we can do is like we actually have we can read each of them into a data frame, right? Because this data actually they are in CSV format. So, let's take Coca-Cola as an example. You can view the file. You can see that there are 2 columns, right? First is the date, and the second is actually the stock price. See that, right? So obviously it's like months, day, and actually this is like year, right? So this months slash day slash year, and then here's the stock price, right? Okay, so the first thing that we want to do with this data is we need to read them in before we can do anything with them, right? Okay, so instead of putting every data can be read in as a data frame, and I do a list so that all of this stock price data frame are kind of like collected in a data object, right? So after I do this and do this, I will have a list, right? And actually, if you press the list, you will see that they are a data frame, right? It's a 480 times 2 data frame, right? You can see that there are two columns within this data frame, right? And P&G, also Coca-Cola, and also Boeing. Okay, so we have 5 stock, but as we can see that the day is when we read in from the CSV file, it will be read in as a character string, right? So first thing we want to do is we want to convert the date into a computer date, right? Before we can do anything, okay? So first thing we want to do is we want to convert the date within each of this data frame, okay, into a computer date. The data type should be date, right? Okay, that there's no time, right? So you need to call the sDate function instead of sPOSITE. Now, here I want to introduce a new function called error_apply. Now, the error_apply function will work like this, right? Because L is actually a list, right? And the list has 5 elements, right? 1, 2, 3, 4, 5. 5 elements. And every element is a data frame, right? So if I want to apply the function class to each of this data frame, you can see that. See, all of this element of L, the 5 element, the type, the data structure of each of the element of L is data frame, right? So if I want to see the element of the list, the class, I can do it like this. So you would apply class function to L to each element of the L list, okay. And then we have kind of like a broader function for error_apply. It's called sApply. Now in error_apply, actually, if you give it a list, it will output a list as the output, okay. But the sApply, if we do it here, you can see that it will actually return a vector instead of return a list, okay. A vector is shorter, right? It's simpler than a list, okay. That's why it's called sApply. So sApply is actually kind of like a enhancement of error_apply, and you'll try to simplify. You'll try to simplify the resultant object, okay, whatever is possible. So in this case, you would simplify the output here, okay. But it do the same thing, right? It apply class function to L, and then the output would be collected as a vector, be simplified as a vector, okay. For example, if we want to return the name of a vector, which is, right, of the list, then it actually, if we apply names to IBM, we will see 2 characters, right? See that? In this IBM data frame, the names is the column names, right? So the column names are all the same. You can see that, right? Okay. If I want to see for example, the number of column, okay, or number of row, I can actually, you can see that every data frame has 480 rows. So error_apply, sApply will help us do repeated action on a list of objects. So you don't have to do it like 5 times, right? You can just do it 1 time, okay? Otherwise, you will need to do like number of row. And L. Right? And then you need to do it 5 times, right? So if you do not do this as apply, you will have to do this, right? Is that okay? So this as apply saves us a lot of effort, is that okay? So the first thing I would like to teach you in this notebook is like you can use the L apply as apply to help us do a repeated action, as I mentioned here. Iterative operation, right? If you want to do iterative operation, you can use L apply or S apply. Okay. Okay. What they do is it actually apply the function to each of the element of this data structure. Okay. And you can actually write a function by yourself. You don't need to call the existing function, as we will see follow. See, now the thing that I want to do here, this code, we actually want to convert. See, up to this point of time, the day is actually a character string, right? And as I told you, we need to convert this character string into a computable date time, right? So I do it, and I want to do it in all of this 5 data frame, right? So what I do is actually I apply this function, okay? And when I call this function, the first time it would apply the function to the IBM. So this df would be the IBM, okay? So the df day is converted to here. And then I want to return the data frame again, right? So after I do this, see that all of this character column will be converted into a date because I'm calling as date, right? Okay, so see that now it become a date, okay? So because this is a date, you can do a plot, you can do a histogram, and you can do a lot of computation as if it was a numeric data, right? Otherwise, the character you cannot see you cannot see it very well, isn't it? Okay. So now, so in this function, with this L apply and with this converting function, and you actually can do it like this, right? Okay. So this is the first thing I want to cover in this notebook. We can use L apply as apply to do corrective to do iterative operation, to apply iterative operation on a collective object. Okay, and you would if you repeat a lot of time, for example, like you have 100 stocks, and you definitely need to do this. Otherwise, you will have to type the command 100 times, right? Isn't it? Okay. Okay, and the second thing that we want to learn in this, again, here are some it is telling you in a 5 data set, all of this have the same number of observations. How many observations are there in each of the data set? So what do you want to do? You can apply now it's very easy, right? I just do a as apply, and I want to see the sorry. I want to see L, and I want to see the number of row. The number of observations is the number of row, right? Isn't it? So Now you can see that all of them have the same number of observation, right? And then it is asking what is the earliest year in your data set, okay? So what do you want to do? You want to do the again, you can use S apply on L, and you want to see the minimum. You want to apply the minimums on the day, right? So you want to write a function. In R, you can do this because every element of L is the data frame, right? And you want to return the data frames day. You want to do a minimum, right? Because you are asking about the earliest year, right? So you do a minimum on the date. Then 0. It's kind of strange. Let me. How about apply? Yeah. Right now you can do L apply. It would be sometimes the S apply when you do the simplification you would make some mistake. Okay, so when the S apply did not work very well, you can go back to L apply. Now you apply the minimum. So you examine each of this data frame, and you see the minimum date, and you can see that it starts from 1970, isn't it? Okay. The latest day, then you simply need to change minimum into maximum, isn't it? Okay. See, we have